Okay, so this is the second part of our um, review on the study guide for the final exam. So number 14, you need to be able to solve a linear equation, and it's going to have parentheses. So the first thing we're going to do is to get rid of these parentheses. So we're going to distribute the 4. This is a positive 4. And so this becomes negative 3x. 4 times 2x is 8x. And then 4 times negative 1 is a negative 4 equal. And then on this side, I just have 6 minus 7x. Combining like terms, a negative 3x and 8x is 5x. So you got 5x minus 4 equals 6 minus 7x. And then remember, in solving a linear equation, you're going to bring all the variables to one side, constants to the other. So I'm going to go ahead and add 7x to both sides. So right now I'm subtracting 7x. So I'm going to add 7x. Notice I'm aligning my like terms. 7x plus 5x is 12x. Minus 4 equal, this is 0, and I get 6. Adding 4 to both sides, since I'm subtracting 4, I get 12x equal, this is 0, 10. And divide both sides by 12. I get x to be 10 twelfths. You got to reduce, which gives us 5 6. And leave this as a fraction. Do not use a decimal. All right, number 15. So number 15, to solve this inequality, notice that you have what's called a compound inequality. So it's a compound inequality, and it's very easy to solve a compound inequality. You're going to get the variable by itself in the middle. So think about if this part wasn't here. If this part wasn't here, you would add 2 to both sides to get x by itself. So you're going to say plus 2, but there are 3 parts, left, middle, right. So you're going to add 2 to all parts, just like this. And so negative 20 divided by 2 is a negative 18. It's less than or equal to negative 3x is less than, and then 22 divided by, 22 plus 2 is 24. All right, now you got to be careful. You got to get x by itself. So if this wasn't here, to get x by itself, you would divide, if all you had was this, you would divide both sides by negative 3, right? But remember, there's another part here. So you have to divide all parts by negative 3. Now, you got to remember this, and this is important. Whenever you divide an inequality, whenever you divide or multiply an inequality, both sides or all parts of an inequality by a negative number, you must reverse the inequality symbol. Only reverse if you divide or multiply an inequality by a negative number. Negative number. So since I'm dividing all parts by a negative number, I have to reverse this. So here's how you read this. Negative 18 divided by negative 3 is a positive 6. Instead of saying less than or equal to, you're going to say greater than or equal to. The negative 3's divide out. 1 times x is x. Remember, you want x by itself right here. Less than becomes greater than. And then 24 divided by negative 3 is a negative 8. All right, now, always, and remember, it's because there's right to solution interval notation. So when writing an interval notation, you always go from smallest to largest. Smallest to largest. So notice 6 is bigger than negative 3. So what you need to do is rewrite this so you don't mess up. So go backwards. So you see how these symbols are pointing in the same direction? So go backwards. You get negative 8 is less than x. You're going backwards. You're reading backwards. Is less than or equal to 6. And so therefore your interval notation, you're going to say negative 8, comma, and then 6 with a bracket. Okay, so remember, see there's no equal sign right here, right? It's just less than. Since there's no equal sign, you're going to use parentheses. Since there is an equal sign, you're going to use a bracket. All right, so that's the answer. Negative 8 to 6. It's important you remember to go from smallest to largest. So from smallest to largest. Don't go the other way, because that's large, that's small. Smallest to largest. Smallest to largest. Okay, now the other thing you saw here was that since I divided both sides, or all parts, by a negative number, I had to reverse the inequality symbol. Okay, you have to reverse. You're not going to do that here. See, you're not going to do any of this, any reversing here. You're not going to, because you're going to be dividing all parts by +4 at some point. You only reverse if you divide by a negative number. Okay, so let's look at this. So if I cover this part up, and you just had this simple inequality right here, the first thing you would do is add 5 to both sides. So in this case, you can add 5 to all parts. Negative 13 plus 5 is a negative 7. Oops, sorry, negative 8, excuse me. Negative 8 is less than 4x, is less than or equal to 3 plus 5 is 8. And then divide all parts by 4 to get x by itself. Negative, now remember, you don't reverse. The only time you reverse is when you divide all parts or multiply all parts by a negative number. This is a positive number right here. I divided all parts by +4. Negative 8 divided by 4 is a negative 2, is less than, 4 is divided out to get x, is less than or equal to 8 divided by 4 is 2. And notice you go from smallest to largest, so you're in good shape. So the answer, in interval notation, since there's no equal sign, you're going to say parentheses, -2, comma, all the way to 2 with a bracket because of the equal sign. All right, so that's the answer. Okay, number 16. So number 16, you need to be able to solve a quadratic equation by factoring. So first of all, keep in mind that if you're going to solve a quadratic equation by factoring, you got to make sure you have 0 on the other side. So we have to put this in standard form. So it's got to look like ax squared plus bx plus c equals 0. And it's got to be in descending order. So when I bring the negative x over, I get 6x squared plus x minus 12 equals 0. And now remember the directions. Always use the directions. Direction says factoring. So let's go ahead and factor this. And so when I factor this, let's see what's going to work. So when I factor it, I'm going to get, okay, so let's see, I'm going to get 3x, 2x, so 3x times 2x is 6x squared. I need the last two to have a product -12, and I need the outer and the inner to add up to be x. And it looks like the only way that can happen is if this is a -4 and this is a +3. Always double check. 3x times 2x is 6x squared. The outer is 9x. The inner is a -8x, which gives me x. And -4 times 3 is -12. Okay, so I factored it correctly. Now the next thing I'm going to use is we're going to use the zero factor property. Remember that, zero factor property. So property, the zero factor property. So when you have a product when you have two factors whose product is 0, excuse me, then one of the factors must be 0. So 3x minus 4 equals 0, 2x plus 3 equals 0. And then you solve each of those linear equations, so get 3x equal 4, so x is 4/3. Leave as a fraction reduced. 2x here equals -3, so x is -3/2. Okay? All right, same thing here. You're going to then put this in standard form. So remember, this is standard form. So you're going to have 0 on the other side and put in descending order. So this becomes 4x squared minus 18x plus 15 equals 0. And then we're going to go ahead and factor this as well. And so when I factor that, I'm going to get, okay, so there's an error here. So let's go ahead and make this 17. This is 17, and this is 17. Okay, so let's go ahead and make those both 17. And so it's factorable. Now before it would not be factorable. So the ones you have will be factorable. So I had to go make this 17. Let's make this, okay, let's go ahead and just redo this part over. So let's make this 4x squared minus 17x equal 15. So let's do that. Okay, so I'm changing this whole thing. Okay, so bringing the 15 over, I get 4x squared minus 17x minus 15 equals 0. And then factoring this, This is factorable now. I'm going to get, let's see, it'll be 4x, x, and then this is going to be a 3, a positive 3, and this will be a negative 5. So let's make sure it works. 4x times x is 4x squared. The outer is a negative 20x. The inner is 3x. That's negative 17. And then 3 times negative 5 is negative 15. Okay, so I did have to change this. Otherwise, it would not be factorable. And the direction says solve by factoring. Okay, so now setting each factor to equal 0 using the zero factor property. I get 4x plus 3 equals 0. X minus 5 equals 0. So 4x equals negative 3, solving this linear equation. And so I get x to be negative 3/4. Over here, I get x to be 5. So those are the solutions. All right, so that was number 16. Okay, so in 17, you need to be able to solve an application problem. And so 6 times the difference of a number in 6 is equal to 3 times the sum of a number in 12. So you want to find the number. Okay, so that's what you're trying to find. And so let's go ahead and let x equal the number. And you're going to write your equation based on how you read this. So notice as you go from left to right, it says 6 times, meaning this, 6 times the difference means to subtract, of a number in 6. So it means, the difference of a number in 6 means this, n minus 6. Okay? Is equal to 3 times, just like this, the sum of a number in 12. So sum means to add the sum of a number in 12. So n plus 12. So there's your equation. So you're going to let, and I'm going to go ahead and put this in. So let n equal the number. So I'm using a variable n instead of x. And now we're going to solve this linear equation. We're going to go ahead and distribute, just like this. And so I get 6n minus 36 equal, and then 3 times n is 3n, and then plus 36. Okay? Let's go ahead and bring all the variables to one side, constants to the other. So I'm going to subtract 3n from both sides. I get 6n minus 3n is 3n, minus 36 equal, this is 0, 36. Adding 36 to both sides, I get 3n, this is 0, equals 72. Divide both sides by 3. I get n to be, and then 72 divided by 3, that will give you 24. So you're going to say the answer. The number is 24. Okay? All right, so that was number 17, example 1. Okay, example 2, same thing, same kind of word problem. This time it says 4 times the difference of a number in 3 is the same as 7 times the sum of the number in 4. You want to find the number. So as you go from left to right, you read out what it says. So your equation, you're going to, well, first of all, you're going to say let x, let's go ahead and this time say x. Let x equal the number. So 4 times the difference of a number in 3. So the difference of a number in 3 means this. X minus 3, difference means to subtract, is the same as 7 times the sum of a number in 4. So x plus 4. All right, and just like we did in the previous one, we go ahead and distribute. And so I get 4x. 4 times negative 3 is a negative 12. 7 times x is 7x. 7 times 4 is 28. All right, so I'm going to go ahead and bring all the variables to the right-hand side. So I'm going to subtract 4x from both sides. So I get, this is 0. So I get negative 12 equals 7x minus 4x is 3x plus 28. Then subtracting 28 from both sides. A negative 12 and a negative 28 is a negative 30. Oops, sorry, negative 40. Negative 40 equals 3x. And then divide both sides by 3. I get x to be negative 40 thirds. Now, in this case, it just so happens to be it's not an integer, but that's fine. It just said a number. So you're going to say the number is negative 40 thirds. Or if you want to write it as a mixed number, 3 and 2, 40. 3 and 40. 3 and 4 is 1. 1 times 3 is 3. Subtract 4 minus 3 is 1. Bring down to 0. 3 and 10 is 3. 3 times 3 is 9. Remainder 1. So you get negative 13 and 1/3. Okay? All right. So that was number 17. Okay. Number 18. So number 18, be able to write the equation of the line in slope-intercept form. So remember, slope-intercept form means y equals mx plus b. Slope-intercept. And so you're going to find the equation of the line described. So you're going to write the equation in slope-intercept form. Slope is 4, and it goes to this point. All right, this is an easy one because you're told what the slope is. So right away you know that m is 4. And then the point is -3, -5. Now, it's very easy to do this one. So if you're going to write the equation of a line in slope-intercept form, you need to know the slope and the y-intercept. I know the slope. The problem is I don't know the y-intercept. Well, if you're going to find the y-intercept, then you have to know an x and a y. So you need to know an x and a y that's on that line, which I do. It's this right here. So there's your x, there's your y. So we know the slope, right? We know the slope is 4. We have to find the y-intercept b. So that's this right here. So I get y, which is 5, -5 rather, equals the slope, which is 4, times x, which we know is -3, plus b. So we got to solve for b. So 4 times -3 is a -12. So we get -5 equals -12 plus b. Adding 12 to both sides, I get -5 plus 12 is, what's that, 7, equal b. And so therefore the answer, because remember you gotta find that equation. Don't just stop there. So the answer, you're going to say y equals m, the slope, plus the y-intercept, which is 7. So 4x plus 7. So there's your answer. Okay. In number 19, you want to graph this line using intercepts. So meaning you got to find the x and the y-intercept. Find x-intercept and y-intercept. All right, so if you're going to find the x-intercept, remember that's where the graph crosses the x-axis. Well, when the graph crosses the x-axis, the y value is 0. So if you're going to find the x-intercept, you're going to let y equal 0. So when y is 0, I get 3x minus 4 times 0 equal 24, because y is 0. So this is 0. -4 times 0 is 0. So I get 3x equals 24. Divide both sides by 3. I get x to be 8, right? So your x-intercept is 8. To find the y-intercept, find y-intercept. That's where the graph crosses the y-axis. You're going to let x equal 0. So when x is 0, I get 3 times 0 minus 4y equal 24. 3 times 0 is 0. 0 minus 4y equal 24. 0 minus 4y is a -4y equal 24. You got to solve for y. To get y by itself, you can divide both sides by -4. -4 divided by -4 is 1. 1 times y is y. So my y-intercept is going to equal 24 divided by -4, which is a -6. Now we're gonna graph the line now. Okay. So to graph this line, remember the x-intercept is 8, right? So that means that's where the graph's going to cross the x-axis. So on your graph, when the x-axis, here's where x is 8, so put a dot there. So there's a point on that line. As an ordered pair, this would be 8, 0. You know that has to be 8, 0, because when finding the x-intercept, you let y be 0. So hence, y is 0. The y-intercept, the graph crosses the y-axis at -6. So here's on the y-axis, here's -6. And as an ordered pair, this will be 0, -6. You know x is 0 because to find the y-intercept, you let x be 0. And then just use a straight edge. So let me go ahead and get a ruler real quick. So to graph this, you're going to draw a line going through those points. All right, so that is how you're going to graph the line. Just make sure you're following directions, because the directions did say you must use intercepts. So you must find the x-intercept, you must find the y-intercept. Okay? All right, so this was the graph for number 19. Okay, number 20, you need to be able to multiply two rational expressions. All right, so in multiplying two rational expressions, you first of all need to factor each of your numerators and denominators. So this is a product right here. You have this rational expression times this rational expression. So let's go ahead and factor this numerator. So when I factor that numerator, I'm going to get x minus 4 times x plus 3. And the denominator, let's see, that's going to be x, so it'll be x plus 6, x minus 4. That's this one here. In the numerator here, I can factor out an x. So it'll be x times x plus 6. In the denominator, I can factor that as x minus 7, x plus 3. Okay. And then once you factor, the next step is to reduce your common factors. So I have an x minus 4 here. I see an x minus 4 here, so those divide out. Make sure you put ones in their place. The next factor I see is an x plus 3. I see one here, so those will divide out. I see a factors in x. I don't see any excess factors down here. I see an x plus 6 as a factor. I see one down here, so those will divide out. And so therefore your final answer will be 1 times x times 1, which is x. And the denominator, 1 times x minus 7 times 1 is x minus 7. And so that's number 20. Okay. Number 21. So in 21, you want to rationalize the denominator. So notice that you have a square root of 10 here and a square root of 7. So the square root of 10 is irrational. So we have what's called an irrational number in the denominator. All right, you want to make that a rational number. So it's pretty easy to do that. So since this is two terms right here, we're going to use what's called the conjugate. The conjugate. And so the conjugate, so let me go ahead and rewrite this over. So you're going to do this, and you're going to say show work. So make sure you show work. Okay? Show work. And so the conjugate, let me go ahead and write down the problem again. So to get that denominator to be rational and not irrational, square root of 10 is irrational. To get that denominator to be rational, you're going to multiply both numerator and denominator by the conjugate of the denominator. So you're going to multiply numerator and denominator by the conjugate of the denominator. So the conjugate of 6 minus the square root of 10, it's easy. You just change that middle sign. 6 plus the square root of 10. 6 plus the square root of 10. So that's your first step. So the first step to make this denominator rational would be to multiply both numerator and denominator by the conjugate. Because remember, what you do to the denominator, you have to do the numerator to keep this equivalent. So remember, this is still 1 right here. 1 times this is still this. All right, now listen carefully. So the best thing to do at this point is to rewrite this as one fraction now. So you have two fractions. So I get 3 times 6 plus the square root of 10 times, and then 6 minus the square root of 10 times 6 plus the square root of 10. Okay? All right, so now what we're going to do is you're going to take this denominator. Let's look at the denominator first. You're going to take this denominator, you're going to multiply that out. So you're going to do this. Let me go ahead and just write it here. Let's do this. So it'll be 6 minus the square root of 10, 6 plus the square root of 10. You're going to FOIL. 6 times 6 is 36. The outer, you get 6 times the square root of 10. The inner, a negative square root of 10 times 6 is a negative 6 square root of 10. These conjugates, whenever you multiply conjugates, the outer and the inner will always cancel out. Notice 6 square root of 10 and a negative 6 square root of 10 have to be 0. A negative square root of 10 times a positive square root of 10 is negative. A negative times a positive is a negative. The square root of 10 times the square root of 10 is the square root of 100, right? Which is 10. So square root of 10, square root of 10 is 10. So you get 36 minus 10, which is 26. So this becomes right here, the denominator becomes 26, which is a rational number. And then just go ahead and multiply the numerator out. So you get 3 times 6 is 18, and then 3 square root of 10. And so there's your answer. Okay? So remember, you want to rationalize the denominator, meaning you want that denominator to be a rational number. 26 is a rational number. Before, square root of 10 is irrational. So this is irrational number down here. To make it rational, you're going to multiply both the numerator and the denominator by the conjugate. So using the same idea here, same thing. The conjugate of 3 minus the square root of 7 is 3 plus the square root of 7. You just change the sign. All you do is change the sign. And so then the next step would be to write this over. 4 divided by 3 minus the square root of 7. You're going to multiply both numerator and denominator by the conjugate of the denominator. The conjugate of the denominator, just change the sign, 3 plus the square root of 7. Just like this. And so now we're going to write this as one fraction. So you're going to say 4 times this, just like this. And then this binomial times this binomial. So 3 minus the square root of 7 times 3 plus the square root of 7. And then multiplying out, 4 times 3 is 12. 4 times the square root of 7 is 4 square root of 7. And then you're going to multiply this out. So I'm going to go ahead and do that right here. So we have 3 minus the square root of 7 times 3 plus the square root of 7. Foiling, we get 3 times 3 is 9. The outer is 3 square root of 7. The inner, a negative square root of 7 times 3 is a negative 3 square root of 7. Since those are conjugates, the outer and the inner will always cancel out. There will be opposites. And then a negative square root of 7 times a positive square root of 7 is a negative. The square root of 7 times the square root of 7. See, this is right here, square root of 7, square root of 7. This right here, square root of 7, square root of 7. It's square root of 49, which is just 7. So this becomes 9 minus 7, which is a negative 2. So we get negative 2 down here. And you can leave your answer like this, okay, which is fine. Or you'll notice that both numerators here, both terms in the numerator are divisible by this denominator. So you could say this, watch, 12 divided by negative 2 plus 4 square root of 7 divided by negative 2, because they're reducible. 12 divided by negative 2 is negative 6. A positive 4 divided by negative 2 is a negative 2. And so you get this. So either this or this is fine. Does not matter. Okay? As long as you rationalize the denominator and and to simplify, just to be honest with you, to simplify, this would be what they would want. Okay? So simplify as much as you can. So you go from here to here. Okay, so that's number 21. Okay, let's look at 22. So in 22, you want to solve this rational equation. So to solve this rational equation, we're going to have to, first of all, find the least common denominator. Because you want to, first of all, clear your fractions. So the least common denominator. So the least common denominator, find the least common denominator, you got to factor all of your denominators. So they're already in factored form. There's nothing else you can do to these denominators. So your least common denominator must include every factor you see. I see an x, I need to use it. I see an x minus 10, I need to use it. I see an x minus 10, I already have it. Don't list it again, otherwise it will no longer be the least common denominator. So there's your least common denominator. Before you go on, though, find your restrictions. So my restrictions, and that could be important along the way. So the restrictions would be any value of the variable that makes the denominator 0, because you cannot divide by 0. So if you look at x, the only real number that makes this denominator 0 is when x is 0. So my restriction is that x cannot equal 0. For this one, x cannot equal 10 because 10 minus 10 is 0. And the same thing here, x cannot equal 10 because 10 minus 10 is 0. So these are the only two restrictions. Okay, the next step is to multiply both sides by the least common denominator. So I get x times x minus 10 times the left side. Now since the left side has two fractions, I'm going to put that in a bracket. 2 divided by x plus 6 divided by x minus 10 equal, and then the LCD times the right-hand side. 2x minus 6 divided by x minus 10. Okay, now let's go ahead and distribute over here to get rid of the bracket. So I get x times x minus 10 times 2 divided by x plus x times x minus 10 times 6 divided by x minus 10. So I'm taking each of these fractions, multiplying by the LCD, as what you see here. So I'm distributing this LCD. And then over here, I can go ahead and, if I want to, well, let me go ahead and rewrite this over. So I get x times x minus 10 times 2x minus 6 divided by x minus 10. Okay, now let's go ahead and reduce. Remember, the whole purpose of multiplying by the LCD is to get these factors down here to be 1s. And they will be because these x's divide out. So I get 2 times x minus 10 plus these x minus 10s divide out. So I get x times 1 times 6 is 6x equal, and over here, these x minus 10s divide out, so I get x times 2x minus 6. Okay, now distributing here and distributing here, I get 2x minus 20 plus 6x equal, and then x times 2x is 2x squared, and then x times a negative 6 is a negative 6x. Combining like terms, 2x and 6x is 8x. I get 8x minus 20 equal 2x squared minus 6x. I want you to notice is this. I went from a rational equation to a quadratic equation. So to solve this quadratic equation, I have to put it in standard form. So let's go ahead and subtract 8x from both sides. So I bring everything to one side. So this is 0. So I get negative 20 equal 2x squared minus a negative 6x and a negative 8x is negative 14x. And then I'm going to add 20 to both sides. So this is 0 equal 2x squared minus 14x plus 20. And I'm going to go ahead and transpose the sides. So I get 2x squared minus 14x plus 20 equals 0. Okay, so the ones that you're going to have will be factorable at this point. So let's go ahead and factor this. When I factor this, let's see what we get. We're going to get this. Okay, so to make things easier on us, we notice that each of those terms here are divisible by 2, right? So I can either factor out of 2 or I can divide both sides by 2 to make it easier. So that's something we're going to go ahead and divide both sides by 2. So let's do that. Let's go ahead and divide both sides by 2. What I do to one side, I do to the other. So 2x squared divided by 2 is x squared. 14x divided by 2, negative 14x divided by 2 is negative 7x. 20 divided by 2 is 10 equal, and then 0 divided by 2 is 0. Now let's go ahead and factor this. So you got x minus 5, x minus 2. And then setting each of those factors equal to 0, I get, setting each of those factors equal to 0, so I get x to be 5 and x to be 2. Now check this with your restrictions. So my proposed solutions are 5 and 2, which are not my restrictions. So if I did all this algebra correctly, then these are your solutions. Okay? All right. Now, most students will not have noticed, by the way, that each of those terms are divisible by 2. So if you did not do that, then notice if you didn't do that, it would have been a little bit more challenging for you to solve, but you can still factor it. Not as difficult or not as easy, but you can still factor it. So let's see, you get 2x, x. You need this to be 20. So the possibilities would be 10 and 2. So let's put the 10 here, the 2 there. The last sign's positive, so that means these signs have to be the same, and they're both negative because of the middle sign. Let's check to see if this is the same as this. 2x times x is 2x squared. The outer is a negative 4x. The inner is a negative 10x. That's negative 14x. Negative 10 times negative 2 is a positive 20. Then you set each one equal to 0. You get 2x minus 10 equals 0. X minus 2 equals 0. Here you get 2x equal 10. Divide by 2. You get x to be 5, which was one of those we found, right? Right here. Over here, this one's easy. X equals 2. All right. So if you did not divide both sides by 2, it's still easy to factor. All right. So that's number 22. Let's look at 23. So in 23, you need to be able to add and subtract radicals by simplifying first. So you see that 32, 162, 72, you're going to be looking for perfect squares. And always use the largest perfect square to simplify. So let's look at the square root of 32. So we know that the largest perfect square that goes into 32 is 16. So the square root is 16 times 2, right? 16 times 2 is 32. And the square root of 16 is 4. So this is 4 square root of 2. So here this becomes 4 times 4 square root of 2. Square root of 32 is 4 square root of 2. Now let's look at the square root of 162. All right, so we get plus 3 times. All right, for 162, you got to be looking at some perfect squares. So remember your perfect squares. Let me go ahead and write it on here. Your perfect squares are 1, 4, 9. Let's see, the next one says, let's see, 1 squared, so 4 squared, 16, 5 squared, 25. 6 times 6, 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and so on, right? Okay, so let's see which of these perfect squares will go to 162. And always use the largest. You must use the largest, otherwise it will be simplified. So let's look at 162, and see which of these perfect squares will go to 162, and always use the largest. So let's divide 162 by let's say 49. Let's see if that'll work. Nope, because that's not an integer. You need a whole number. So let's do 162 divided by 64. Nope. All right. Then let's do 162 divided by 81. Yep. Okay, that's the one, because 2 is a whole number. So 81 goes in 162. So you're going to say 1 square root of 162 is the square root of 81 times the square root of 2. And the square root of 81 is 9. So this is 9 square root of 2. So that goes here. So times 9 square root of 2. Then minus 6, and then do the same thing with 72. Square root of 72. Well, that one's easy because we know that 36 goes into 72. So it'll be the square root of 36 times square root of 2. Square root of 36 is 6. So you get 6 square root of 2. So that's 6 times 6 square root of 2. All right, so simplifying this, we got 4 times 4 is 16. So you got 16 square root of 2. 3 times 9 is 27. So you got 27 square root of 2. And then minus 36 square root of 2. So notice all of these terms are like terms because they all have the square root of 2 in it. So let's do it in order. 16 square root of 2 plus 27 square root of 2. 16 plus 27. 16 plus 27. 27 equals 43. So this is 43 square root of 2 minus 36 square root of 2. So 43 minus 36 now, 43 minus 36 will give us 7. So the answer is 7 square root of 2. So that's number 23. There's your work. Okay, so you must show work. Okay, number 24. So be able to solve this quadratic equation, use a quadratic formula to solve this equation. So this one will involve imaginary numbers. So remember the quadratic formula is this. So it's the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So this is in standard form. Once it's in standard form, then you need to denote what a, b, and c are. So a is a coefficient of x squared, so that's 6. B is a coefficient of x, so that's negative 3. And c is your constant, which is a positive 1. Once you find a, b, and c, you're going to substitute into this formula. So we get x equal, remember this reads the opposite of b. So b is a negative 3. The opposite of a negative 3 is a positive 3. Plus or minus the square root of b, put that in parentheses. B is negative 3. But whatever b is, you got to square it. So you see what I'm doing here, squaring it. And remember, I'm putting b in parentheses. Minus 4 times a is 6, put that in parentheses. And c is 1, put that in parentheses. All divided by 2 times a is 6. Now at this point, you're going to simplify the radicand. So it becomes 3 plus or minus the square root of, simplify the radicand. Negative 3 times itself is 9. A negative 4 times 6 times 1 is a negative 24. All divided by 2 times 6 is 12. Equal 3 plus or minus the square root of 9 minus 24 on your calculator. Figure that out. 9 minus 24 is negative 15. All divided by 12. Okay, now you got to remember that the square root of a negative 1 is defined to be I. Square root of a negative 1 is defined to be I. So the square root of a negative 15 will be the square root of a negative 1 to the square root of 15. Square root of negative 1 is I, so you get I square root of 15, and square root of 15 cannot be simplified. So here's your answer. Your answer will be 3 plus or minus I square root of 15 over 12. So be careful. If you leave it as this, you're going to lose a few points. So you have to know that the square root of a negative 1 is defined to be the imaginary unit I. Okay, so the square root of a negative 15 is not a real number, so that's why we talked about imaginary units, by complex numbers. Okay, so that's 24. And then finally 25. So let's get to 25. So be able to use the square root property to solve quadratic equations. This is easy. So use the square root property to solve this equation. So let me go ahead and rewrite this over. And remember, you're going to show work. So we get x minus 6 squared equal 81. So to get x by itself, notice right now I'm squaring x minus 6. So you got to do the opposite. The opposite of squaring is just take the square root of both sides. But remember, when you take the square root of both sides, that's where you're going to get a positive and a negative. So you must remember that. Remember, positive and a negative. So the square and the square root undo each other. So you get x minus 6 equals plus or minus. This one's easy because 81 is a perfect square. So the square root of 81 is 9. Once you get to that point, I want you to notice that I can rewrite this in two ways. X minus 6 equals a 9, positive 9, and x minus 6 equals a negative 9. So x minus 6 equals a positive 9, x minus 6 equals a negative 9. And then solving each of those linear equations, adding 6 to both sides in both cases, your solutions, this is 0, 9 and 6 is 15, a negative 9 and 6 is a negative 3. So those are your solutions. So 15 and negative 3. So your solutions are x equal 15 and x equal negative 3. Okay? So that is the study guide. Let me go ahead and find the original. So that is the study guide for the final exam. Okay, so that's the study guide for the final exam.